In today's lecture, we are dealing with the Turing machines, which is invented by Alan Turing in 1936. It is a automata to accept recursive enumerable languages, and which is also called as type 0 language. I remind you that context-free languages automata is push-down automata. For regular languages, it is finite automata. And here I remind you the Chomsky hierarchy of languages. Type 0 is unrestricted grammar, unrestricted language, recursive enumerable language. Type 1 is context sensitive language, and the corresponding machine is linear bounded automata. For context free languages, which is type 2 language, the corresponding automata is push down automata. There is another type is type 3 language, which is regular language. The corresponding machine that accepts is finite automata. There is a language, there is a grammar, and there is a corresponding machine that accepts corresponding automata that accepts the corresponding language. For type 0 language, and which is also called as recursive enumerable languages, the automata that accepts the accepted machine is Turing machine. You got my point? The main features of Turing machine are having external memory that remembers long sequence of input. Actually, in earlier, regarding this context-free languages, push-down automata, or regular languages, finite automata, whatever the tape that we deal with is going to be labeled as input tape. You got my point? But in Turing machine, whatever the tape that we deal is, it is not only input tape but also a output tape. That means we can able to perform not only read operation on the corresponding tape but also write operation on the corresponding tape. And moreover, memory is unlimited. And moreover it is unbounded. Unbounded means both ways there is no boundaries. You got my point? It is open in both ways. Both directions movement on tape is allowed. That means from right to left or left to right, we can able to move the tape head. Read write head. You got my point? Output can be mentioned on input itself. Read write head pointer reads input, writes output. You got my point? Here what we have is a input tapes, a tape and the corresponding a finite control, where the tape is capable of both input and as well as output. That means we can perform read operation on that one and we can perform write operation on that one. That means whenever we are going to process a input symbol, we can able to whatever the output that is generated by processing the input symbol, we can able to write the corresponding processing output on the corresponding tape itself. You got my point? Whatever the tape that we deal with in Turing machine is not input tape, not restricted to input tape. It is also a output tape. That means whatever actually you can simply it is a memory. It is input. Whatever the tape is a memory where we can able to read and write. And that memory is unbounded and unlimited. Whereas in context free languages, we have memory in terms of a stack, which is also unlimited, where we have a input tape over there. That means whatever the input tape, whatever the input symbols from the input tape, we just process and we will do the whatever the processing through stack. Whereas in Turing machine, the tape that we deal with is not only input tape but also output tape. It is capable of both read and write operations. You got my point? This is the main extension from the context free languages push down automata. You can simply know this is the abstract diagram of Turing machine. A tape, and there is a finite control, and there is a read write head. This is the extension write. We can able to perform write operation as well. We have some blank symbols, and we have some input tape symbols, and you can see that there are three dots in both directions. That means unbounded in both ways, both directions. Unlimited, I mean, in both directions it is unlimited. We can extend as much as possible. You got my point? Simply we can able to define Turing machine as a mathematical model of computation, describing an abstract machine that manipulates symbols on tape according to table of rules. It is capable of implementing any computer algorithm. You got my point? It is whatever the algorithms, that mean whatever the things that we can able to do with the computer can be uh, constructed by using a Turing machine. And most important point over here is the Turing machine is somewhat slower uh, in terms of performance. If at all you are going to implement the corresponding algorithm through computer, through Turing machine. Actually, there is a thing called Turing test. If something can be done with a computer, can be done with a computer, that can be tested with a Turing machine. That means it has a Turing machine. You can take in a vice versa. I mean, if something can be done, there should be a Turing machine. If there should be a Turing machine, then we can able to develop an algorithm for that one. Vice versa. You got my point. That is going to be called as Turing test. And whatever the Turing machine can be represented by using a 7 tuple. Of course, push down automata is also a 7 tuple, and finite automata is a 5 tuple. In push down automata, we have stack related 2 symbols. Same way in Turing machine, we have tape related 2 symbols. The one that is extra from finite automata is X, corresponding X in tape symbols, and the corresponding B is the blank symbol. You got me? These are the 2 extra symbols from the finite automata 5 tuple value. You got my point? Whereas in earlier push down automata, we have stack symbols. I mean, stack symbols are tau, and the corresponding initial stack symbol Z0 for PDA. For Turing machine, X, B for blank, X for tape symbols. You got my point? We cannot pronounce the tape over here is input tape. Remember that point. We have 7 tuple representation of Turing machine. Capital Q set, a finite set of states, sigma input alphabet, X tape symbols, delta. This delta is nothing but a transition function, where we have transition function from Q cross X set of states, finite states cross tape symbols gives rise to Q cross X cross L. L means left, R means right, SRH means S for stop, H for halt. Some textbooks representation is S, some textbooks are using H for halt, S for stop. You got my point? These are the contents of a transition function. Q cross X, cross either left side or right side. I mean, whatever the movement, read right ahead movement can be mentioned by using this direction. Same way we have initial state Q0, B for blank symbol, F for set of final states, which is a subset of capital Q. Whereas we can able to represent whatever the transition from Q1 to Q2 by using this representation. Here the small a is input tape symbol, input symbol. Capital A, this is the processed output. That means by consuming input A, we are writing capital A on the tape. You got my point? This is the capital A, that means processed output. this is the one where the corresponding next for the next input symbol, we are in the direction of right side. You got my point? Tape direction, tape read right head direction. You got my point? In this way we can able to q cross a, q1 on a, q1 on a, q2 on capital A. This is the output symbol. This is the direction where the further transition on the corresponding tape. You got my point? In this way we can able to represent the corresponding Turing machine. I mean by processing the x1, we are making capital A over here and we are moving towards the x2. That means R means towards x2, L means towards B, capital this B. You got my point? R, L, S or H. That means in simply we can able to mention the corresponding direction of the where we are going forward in the on the corresponding tape. Very important point, this direction. Remember that 2 values on the left side, 3 values on the right side. You got my point? Whereas in push down automata we have 3 values on the left side and 2 values on the right side. You got my point? Here we have some difference is there. Very important point. Note it down. We covered the Turing machine, and actually there is an example related to this Turing machine that we will cover in the next lecture.